The concept of electric charge is not clearly and thoroughly explained in physics. Furthermore, the difference between charges with different signs is not explained in detail and accurately. If we speak, so to say, strictly according to the textbook, then electric charge is a scalar physical quantity that essentially represents the amount of electricity. And there is really no better way to put it than to say it is the amount of electricity. But here, it probably makes sense to recall how all of this has historically formed. We understand that different abilities to engage in various electric and electromagnetic interactions are characterized by the specific behavior of a body. And if you analyze where the logic of electric charge originated, you will come to those very examples that we study somewhere at the beginning of the physics course when we encounter electricity. Initially, this was explained very simply. If we rub our hand against a cat and experience some unclear physical phenomenon, then most likely, when we interact with the cat, we are pulling some amount of some unclear material from it. However, this is exactly how the behavior of charge was initially explained. It relates to the very amount of electricity that we mentioned from the very beginning. In fact, it turns out that if we touched a cat while petting it with our hand, we transferred some amount of something to that hand. And what is this something? However, to jump ahead, I will say that modern physics is also unable to fully answer what it is, but at that time a decent and quite objective model was proposed and developed, and it even worked quite well. It was assumed that when we transfer some amount of this unclear material, referred to as electricity, we are taking away from the cat a certain amount of an unclear substance called electric charge. We take some amount of electrons from the cat, and here everything relies on the specifics of the structure of the atom. We remember this theory regarding the fact that an atom has an incorrect number of electrons on its surface, in the outer layer. In fact, these free electrons can be easily pulled away in interaction with this surface, with this object. The counterbalance to this was the positive charges. And an example or standard of positive charge is, of course, protons. It was impossible to separate protons from an object simply by losing combs or other items. Thus, it turns out that if a body has a net electric charge, it means that the body has an excess of electrons. There are more electrons. If a body has a positive electric charge, it means there are fewer electrons and therefore more protons. But unfortunately, all these ideas do not answer the question about the true nature of what is happening, and this is precisely the most interesting part.